Hey guys, Eric with Verus Engineering here, and today I'm going to be going over Design 101, or a design process for us to take a product from an idea to a final product, and specifically from, say, this stack of papers to actual products that you see on the table here. We've seen multiple customers and business owners' jaws drop when we say we have hundreds upon hundreds of drawings for every single product we've ever produced. And by that I mean a drawing that is fully dimensioned, fully defined, basically a contract with the manufacturer on what we expect and need to be built. This isn't always common knowledge, but it is a necessary component of manufacturing a product properly, repeatedly, and continuously. So it is a necessary function of our business. So in today's video, I will be going through a single component which goes through scanning, the design process, the analysis process, the revision process, and finally the production process, which is the parts you see in front of me. Most of our products start with a vehicle scan of some sort. I'm going to keep this very brief, as I just finished a Scanning 101/frequently asked questions blog and vlog, so you can go watch and read those. But basically we scan the car to gather data for both CFD and CAD design. So now that we have the scan data, now comes the fun part to us. We get to design a part from scratch, utilizing past experiences and our best judgment on what it looks aesthetically pleasing for the vehicle. In this case, it's a rear diffuser for the 981 GT4. So we basically pulled on past knowledge and what we thought looked great while still functioning and designed that. This entire time we have to keep in mind that the product has to fit within a specific build volume. For us, it has to function and it has to be aesthetically pleasing. We also attempt to keep all mounting points on the chassis so that you do not have to drill any holes or do any permanent damage to your vehicle. So that's another thought that we keep in mind as we design products for the car. At this point, we take our initial designs and we import them into our analysis software, which is ANSYS. ANSYS is a state-of-the-art analysis software which basically leads the field in CFD analysis and FEA, as well as some other analysis softwares we personally don't use, but they are very high-end analysis software. Again, I'm not going to go in too much detail here, but because we will be creating another blog and vlog on ANSYS's abilities and what goes into every analysis, but we ensure that every analysis has proper boundary conditions, rotating wheels, a good quality mesh, and finally, the correct turbulence model. From the initial analysis, we'll then look at a bunch of post-processing images, as well as the numerical data, which is ZD, CL, and aero balance, or coefficient of drag, coefficient of lift. We look at all the data and then we attempt to improve upon our initial design. Not always do our initial designs actually improve vehicle performance. Sometimes they actually hurt it, so we have to go back to the drawing board and create something from scratch. This is one of the reasons why we do analysis and we preach that we have to do analysis, because not always do products actually improve performance. Luckily, we have the ability to improve and ensure that our parts function before we even produce them. It's a very neat feature to have, and that's why we stress on it so much. When I say that we optimize our products, we basically look at post-processing data, and sometimes we manipulate the geometry ourselves. Other times we have ANSYS's Adjoint Solver, which is an optimization software within ANSYS, do the optimization for us. ANSYS has the ability to actually morph the geometry of our parts, if we specify it, to improve performance. And sometimes we let it do that. We did that with our rear wing, and we've done it with some of our other diffusers. So from the CFD design, we take that model, which is optimized or improved upon, and we create a manufacturable model. So the model within the CFD design, CFD analysis, is not exactly always manufacturable. And what I mean by that is sometimes the parts are thicker, sometimes the parts do not have a uniform surface thickness, sometimes the parts don't have mounting hardware because realistically this does not influence the CFD analysis. So we have to create then a manufacturable part within 3D CAD. That is just basically these specific designs. Also, generally speaking, the parts probably will not have holes in CFD. Those will be filled in, so we have to create and add holes. The bolts aren't there, etc., etc. From the 3D design that we just made, we now have to create 2D drawings. And when I say we need to create them, we need to create them. If another company is not creating 2D drawings for every component, I'm not sure how they're manufacturing products, to be honest. The 2D drawings basically give dimensions of every product, every component of the product, and is a binding contract with the manufacturer on how to make it. At every business I've ever looked into and manufactured with, they require 2D drawings. So it is essential to produce these 2D drawings, which a lot of people don't even realize exist, and how much time they actually take, because some of these products have 50 to 100 dimensions, and then you actually have to dimension correctly the part so that as they're manufactured, they stay within a specific tolerance and fit every vehicle, etc., etc. It's very difficult to understand unless you've done it before, but basically every single component has these 2D drawings. So this diffuser that you see right here, without this underbody panel, flat underbody panel, it requires 11 drawings to be reproduced. One assembly drawing, about 5 sheet metal components, 2 plastic components, and 3 carbon fiber components. Each one of these drawings needs to be fully dimensioned with correct tolerancing, and then the components can be produced. So utilizing these drawings with the 3D CAD, which we end up sending to manufacturers, the components you see before you are able to be produced. In conclusion, I hope you learned a little bit about what goes into the design process here at Verus Engineering. We consider these fairly standard practices for the industry and for other industries as well, and something basically any manufacturer or design firm should be able to and be capable of doing. It's essential for components to be repeatable, for quality control, and for components that continually fit on vehicles throughout the build cycle. I hope you learned something, and thank you again.